The ggplot2 package creates graphic visualizations layer by layer, rather than providing pre-made graphs. There are many directions that this package can be taken graphically, including histograms and density plots, scatter plots, time series graphs, and more. The overall purpose of ggplot is to create complex, multi-layer graphics that don't require much work at all on your part because it does everything for you. After installing ggplot, you can import a dataset into R that you want to visualize and think about how you want to visualize it. You can determine the aesthetic properties of the graphs like the size, color, and X and Y locations. Finally, you can build the graph and add additional layers to it. Additional layers can include multiple geomes, text, annotations, and scales. For new users, there is extensive documentation online at ggplot2.org.
Before we begin writing ggplot code, it is important to understand the basic structure of a ggplot visualization. There are three components of ggplot graphs: a call to ggplot, which specifies the dataset and aesthetic mapping, declaring X and Y; a geome, like geome point or geome bar, which layers on a graph; and layers, including annotations, scales, guides like axes and legends, faceting, and themes. Because ggplot builds graphics component by component, there are endless possibilities for different visualizations. In this video, we will show you how to create time series graphs, histogram and density plots, and use faceting.
One very useful feature of ggplot is the ability to create time series plots, which display values over time. To plot time series data with ggplot, simply ensure that the date column of your data frame is of the date class in R. ggplot will do the rest. In the following plot, we input the name of our data frame, weather, and specify X as the date column and Y as a temperature column with a call to ggplot. From there, we define the geome to be a line with geome_line, where its color changes depending on the temperature statistic. This can be seen in the plot shown. However, there are several more features that can be added to make this plot better. We can specify the theme of the plot, customize the axis scales, create labels with labs function, and add a trend line with stat smooth. Once we add these aspects, the plot can look like this. Ta-da!
Perfect.
Beautiful.
Okay. In ggplot, we can create density plots with geome density. First, we specify the cars dataset and the variable mpg in our call to ggplot. In geome density, we specify another aesthetic, fill, which changes the color of each density plot based on the type of car. This code results in this plot. We can also customize this plot by adding labels, a black and white theme, and a new color palette which looks like this.
One of the most popular features of ggplot is the ability to layer on multiple levels of information. After we call ggplot, the first layer of information comes from geome histogram, which we color based on the type of car with another aesthetic definition. We also adjust the number of bins and other characteristics, creating this graph. From there, we can layer on a facet wrap. This divides up the plot into subplots for different car weight bins. We also can add a new theme and color palette.
If you want to learn more about ggplot, there are many resources available. One of the simplest ways is going onto Polylearn and looking at the data visualization cheat sheet. This cheat sheet has a brief overview of some of ggplot's capabilities. Another option is to type $geome into the console to see a comprehensive list of parameters and aesthetic mappings. The ggplot documentation online is also a helpful resource. If those methods do not work for you, you can always read one of the many books available, like Data Visualization with ggplot2 by Rick Scavetta or the R Graphics Cookbook by Winston Chang. Next time you need to make a visualization, we hope you consider ggplot. Thank you.